Hi, my name is Molly McKay, and for my systems problem for 1.4, the first module, I chose melting of the polar ice caps. So in this systems problem, I'm looking into the relationship involved with the melting of the polar ice caps. This is a large problem currently because it's one of our detrimental effects from global warming. Melting polar ice causes a loss of habitats for humans and animals as well, and it also contributes to rising sea levels, which puts other people and other animals in danger, especially those living in low elevation coastal areas. It has many other detrimental effects, but these are the ones that specifically correlate with what I'm looking into today. So to start out, to look into the problem, I examined what was involved in the simple equation of the polar ice melting. So stock items involved include sunlight, polar ice, exposed seawater, Earth's albedo, and water temperature. This gives me a basis of setting up the flow model, which creates a positive feedback loop, which I'll eventually show, which reinforces the action and aggregates the result. So according to the National Geographic website, throughout most of 2016, conditions in the Arctic were anything but normal. In mid-November, a month before the full onset of winter, the Arctic Sea actually began to melt. More than 19,000 square miles of ice disappeared. So really, this involves the albedo increasing once the ice is melting. So the melting is actually causing more melting, which is kind of funny, but that's one of the phrases that I saw when I looked it up. A typical ocean albedo is approximately 0.06, while bare sea ice varies approximately from 0.5 to 0.7. As you can see, the ice increases Earth's albedo dramatically, which then increases the amount of solar radiation incoming to the system that gets reflected. So it reflects 50 to 70% of that energy rather than absorbing it. So exposed seawater absorbs 94% of that heat, and the bare sea ice only absorbs 30 to 50% of that heat. So looking into a way to keep the ice from melting would keep the albedo up. So there just needs to be a way to add in some sort of reflective material that keeps the reflection rates up and lessens the melting, which then would have led to more melting. So, this is the second attempt that I created. This is not including what I'm going to talk about next, which is my possible solution. So this is just my second attempt, and then I looked into this. So this feedback loop shows the positive loop that I've been explaining. And then I went ahead and created the final diagram without the solution yet. So as you can see, the sunlight, polar ice, exposed seawater, albedo, and water temperature are all involved, including the melting rate and rate of reflectivity, which creates the positive feedback loop. And then here I just did a little explanation about what my thinking was behind creating that flow diagram. So just the more sunlight means less polar ice means more exposed seawater equals a higher or more light absorption, but technically a lower albedo, and then higher absorption of the heat increases the water temperature, which the water temperature then lessens the polar ice, and it just aggregates those conditions as I mentioned earlier. So when looking into step away from this reinforcing feedback loop, that would just continue to aggregate and melt the polar ice caps, I came across a couple of different ideas. The main idea that I focused on was how to keep Earth's albedo around the level that it would be if it had ice, and find a way to maintain that albedo to deter the warming and direct the solar radiation on the ice, or away from the ice. So one idea involved the organization called ICE 911, which proposed the idea of scattering tiny naturally occurring glass spheres that would not have any negative effect on the organisms across the parts of the Arctic to reflect more sunlight back into space and slow the thaw. So the glass spheres would be made from silica, and they would look like small hollow grains of sand. Because silica's material is abundant and it's in the natural world, it would be harmless to wildlife, and it's the perfect contestant. These glass beads would work to increase the surface area of the water that is covered by reflective material, similar to ice. They're a natural component in many sands, and if they did end up getting punctured, because they are hollow, so they would float, so if some of them got displaced. They're a natural component in these sands, so they would have little to no harm done and just enter back into the ecosystem as sand product. So with this solution in mind, it's basically scattering all these little silica glass beads all over the top of the ice and the surfaces of water to add more reflection and lessen the absorption of heat. So with this in mind, I created a new feedback loop that includes this deterrent. And so this is my new configured feedback diagram. So I have the solar radiation pointing to polar ice, and then I also include the normal one, which would lead to more ocean exposure, which is a lower albedo, and then increased heat absorption. So as you can see, this small triangle is the same as it would have been before, but then added in with the silica glass then leads to lower exposure, which is a higher albedo, lower exposed ocean water, which then leads to decreased absorption, so increased reflectivity of the solar radiation, which then would lead to cooler water temperatures, which would then not continue the melting of the polar ice. It would bring the polar ice back to a normal state with no melting occurring, or much less melting occurring at that rate. So the reflectivity of both the silica glass and the polar ice could be utilized in this situation. Obviously, this isn't an end-all solution. It's a work in progress to try to keep the polar ice caps from melting specifically as quickly as they are. But yeah, so this is the solution that I was able to look up online and find some background on and then put it into this situation. So that is my solution to the feedback problem, to my model system problem, which was the polar ice caps melting. And then here's some of the websites I used to figure out the solutions and then just see the feedback loop altogether. Hope you enjoyed and learned a little bit more about the ice caps melting and the albedo effect. Thank you.